The mathematical blueprint. Mapping the invisible flow of vector fields. The core of this exploration lies within the derivation sheet, which acts as the foundational blueprint for understanding how energy or fluid flows through a spherical surface. Rather than being a mere set of calculations, this document serves as the source of truth that defines the fundamental rules governing the entire system. It establishes the crucial discovery that the behavior of a flow depends entirely on the nature of the field's power, revealing a world where symmetry can either perfectly balance out a force to nothing or amplify it into a measurable total. This foundational logic is what breathes life into the sequence diagram. If the derivation sheet is the blueprint, the sequence diagram is the operational engine that executes those rules. It illustrates the internal decision-making process. First, it consults the derivations parity filter to determine if the field is symmetric enough to cancel itself out. By following the logical workflow established in the derivations, the sequence diagram shows how the system chooses between different paths, either concluding that the total flow is zero or triggering a specific formula to calculate a positive result. It bridges the gap between abstract theory and the interactive animations that visually prove these concepts. While the sequence diagram manages the internal logic, the state diagram maps the conceptual journey of a learner moving through this material. The significance of the derivation sheet here is that it provides the milestones for this progression. The state diagram shows how one moves from a basic calculation to a direct verification phase, where the derivations prove that two different mathematical paths lead to the same destination. It then uses the derivations' insights into symmetry to transition into visual demos, explaining why we see specific color patterns on a sphere's surface. Finally, it pushes the boundaries of the original derivation by exploring what-if scenarios, such as shifting the sphere's position, which breaks the established symmetry and introduces a new level of complexity known as translational variance. Together, these two diagrams transform the static principles found in the derivation sheet into a dynamic and navigable experience. One provides the logical how-to, sequence, while the other provides the pedagogical where-to-next, state, both relying entirely on the underlying mathematical reality that symmetry is the ultimate arbiter of flow.